Hello, good day to everyone. If you are new in this channel, please do like and subscribe, and you can tick the notification bell. So thank you for that. So we'll proceed now to our lesson for today, which is basically about linked list structure. So linked list structure is one of the abstract data structures or data types that is included in the data structures discussion. So let's define a linked list. So basically, we have found out that we already know that data structure is composed of nodes, and each node holding some information and a reference to another node in the linked list. So a linked list is basically a linking of the different reference to another value or another reference. So we do have what we call a singly linked list if a node has a link only to its successor in a sequence. So singly linked list is a node na there are two data fields. First is the info, so it is referring to the information or the value that is residing or stored in the linked list, and then next. So next is basically it is used to link together nodes to form a linked list. So it will be linking to another block of in another block of nodes. So this is an example of singly linked list. So again, pag singly linked list, there are only two information, the info and then the next. So example, we do have a P linked list here. Okay, we do have a P linked list. Okay, we do have a P linked list. So this is basically the info and then the next. So example, if our P has one node, so the node here is 10. Okay, the node here, its info is 10, and then its next is forward slash. As you notice, the next is forward slash because it doesn't have anything to link with, because it still doesn't have another node okay next to it. And so if we want to add another node, so the next information of the node 10 will basically point to the information on the next node, which is 8. So this node here is referring to the node right here, which is 8. So if we are referring to p.next.info, then we are referring to the value 8 or the info 8. And then if we are referring to p.next, we are referring here. And then if we are referring to p.info, we are referring to the 10, which is the first info. And then if we are referring to p.next.next, we are referring to the next reference here. So ito yung forward slash. It is empty because it doesn't have another node next to it. Then we will add another node basically after the 8. So again, if we are referring to p.info, we are referring to the first node information, which is 10. If we are referring to p.next, we are referring to the first node next field. Ito yung field info, next field. So pag p.info, ito yon yung 10. Pag p.next, ito yon. Pag p.next.info, kasi p.next.info, so p.next.info, we are referring to field 8. But if we are referring to p.next.next, okay, I'll use a pen para mas klaro. If you're referring to p.next, so p.next.next, so we are referring to the whatever the address written in the next field of the second node. So take note that in linked list, it is important to identify what is the head and what is the tail. So the head here is our 10. This is our head. And then our tail here is the node 6. So again, if we are referring to p.next.next.info, we are referring to the 8. Okay? To the 6 rather. p.next.next.info, we are referring to the node 6. If we are referring to p.next.next, we are referring to the p.next.next and then .next. So we are referring to the empty address of the third node of the next field of the third node, which is an empty because again it doesn't have any node next to it. So we'll proceed with how to insert a node in our linked list. So these are just simple steps. First is an empty node will be created before the head. So the new node's info field is initialized to a particular value. So yung first information field, which is the information, must have a value. And then the next field becomes a reference to the first node on the list. So the new node precedes all the nodes on the list. So in theory, you may insert a node only from the head or tail. Okay, so you can insert before the head or after the tail, in theory. So example, we do have here a linked list. We do have two nodes here, 10 and 8, and then the head here is 10, and then the tail here is 8. So you can add again. You can add a node before the list, before the head, or after the tail. So again, an empty node is created here before the head. So you can also add here after the tail. It depends on the operations that you are executing. So in this case, we are adding a node before the head, and it is initialized with a value which is 6. And then the next field, ito yung next field niya, is referred or pointing to the the info field of the next node, which is 10. So the new head now is 6, and then remain lang yung tail. So it's still the same. If we will add another node here in the tail, let's say this will become 5. So this will be now the new tail, and then itong empty na next field of the third node will now have a reference address referring to the info field of the fourth node, which is the 5. And then ito empty siya nga because it is now the tail, so the next node will be empty of the tail na node. And the next field of the tail node will be empty because wala nga siyang next node basically, or a node next to it. So we'll proceed with how to delete a node. So again, it's similar with deletion, insertion. We can only delete from the head or the tail. Sorry, may kulang dyan. So we can only delete from the head or the tail, in theory. So in theory, we can only delete from the head or tail. So we basically, this is our example. We do have 3 nodes. Let's say for example, we want to delete the head, yung nasa unahan ng linked list. So the data in the info field of the head node will be temporarily stored in a local variable. So ito maging stored in a local variable, itong info field, and then the next field will become, okay, so this will be stored in a local variable, and then yung head pointer will now be pointing to the whatever node pointing to the next field. So kasi the original head node is pointing to the 10 na node. So if we are deleting the node 6, so the new head pointer will be pointing to 10. Then after that, the reference of the original next node, which is now in a local variable, will now be erased. Okay? And then the former first node will be abandoned. Okay, ma-abandon na ito. And then it will be collected by the garbage collector of the programming language that you are using. So in our case, if we are using Java, so it will be collected by the garbage collector of the Java or of the Java IDE. I mean the Java virtual machine. Another type of linked list is the Doubly linked list. So in Doubly linked list, it consists of 3 fields. So we do have the info, the next, and then the previous. So this is the head. And then the third one, it is referring to the, so the second, the first field is the info. Okay. So the second field is the next. And then the third field is the previous. Okay. So like what is representing here, the next next field is referring to the node 10 and then so on. And then the third field is referring to the previous node. Example, on the 10th node, ang prev niya is referring to the previous info or previous node info. Now, for the tail next in doubly linked list, so ang nangyari dito is empty because nga walang node here sa next of the node 8. And then the prev of the head node is also empty kasi walang node before the head. Okay, so empty lang siya. So that is doubly linked list. Meron siyang info, merong next, and then merong previous. The info field is basically storing the data. The next field is referring to the next info, and then the previous is referring to the previous info of the previous node. Another type of list is circular list. A circular list is formed by making use of variables which would otherwise be null. And then the last element of the list is made the predecessor of the first element, and then the first element is the successor of the list. So let's go back again in our doubly linked list. The successor of the tail node, yung next niya, di ba empty? So that means nag-end na doon yung list. So, and then also in the head, the previous niya is empty. So that means wala siyang referring to a previous node. So it's different with circular list. The next node, the next field of the tail, so ito yung tail, di ba? So itong next node niya, it is referring to the yung current yung first or the head node. Okay? Di ba dati yan siya? That's empty. Now in circular list, it's different. The next node of the tail is the next field of the tail is referring to the info of the head node. Okay? Okay. Now, searching, when you want to search for a node, it basically starts from the head to the tail. Okay, so when you want to search, let's say 10, so the searching will start in the head and then up to until it will found the value, which is 10. And then if it will end until to the tail node, it will not found anything, so or any equal to the node, the info that we are looking for, so it will be the searching will be terminated. Okay, so in usual values in Java, it will return -1 because the node that you're looking for is not existing in the linked list. So if the node is found, so the searching will return the value of the info. Okay? Now, we'll proceed to an example searching and retrieving in a circular doubly linked list. So, in circular doubly linked list, it does have a info, next, and prev. Okay? So, pag pag doubly linked list, di ba, tatlo dapat yung field, the info, the next, and then the prev. And then, pag circular list, if you can remember, then it is circular. That means the tail, ito yung tail, I'll use pointer. So, ito yung tail. The tail next will be referring to the info of the head node. And then the prev in field of the head node is referring to the info of the tail node. Okay? So, to represent that, ayan. So, this is the next field referring to the next info of each nodes. As you notice, I placed a address, just arbitrary address of each of the next and then the prev field. So, ito yung mga address. In order for us to uniquely identify the address of the next and then the prev field. Okay? Right, so our okay, so that is for the next field. And then again, itong next na next ng tail node is referring to the info of the head node. Ito, this is the head node. And then for the third field, as I've said, all third field is referring to the previous info. Okay? And then the node of the prev field of the head node is referring to the info field of the tail node. Yan. So, okay, this is the info, next, and prev. So, I'll be giving out some questions and then you try to answer on your own what is referring on each of these, each of these items. Okay, ano yung mag-return on each of these items? Example, for number 1, list A, let's say we call this list as list A. So list A dot next dot next dot next dot info. So what will be returned? Okay, for my students, please do answer it on your own. I'll be asking one by one on our virtual meeting what will be your answer. Now, for our other viewers of this video, I'll be giving out the answers a week after posting this video in YouTube, and then the answers will be posted in the comment section after a week. Okay, so array list versus linked list. So, di ba, we have discussed about array list. So, we have known that array list can grow and shrink, and array list uses dynamic array in order to store elements, while linked list it uses linking of elements. That means doubly linked list or simply linked list. And array list, it's basically slow because it uses an internal array in manipulation, because if you want to remove or add elements, it will need to create another array and then copy the elements in the old array into the new array. While in linked list, it is much faster in adding or inserting or deleting elements because it uses doubly linked list. So there will be no bit shifting required in the memory. While in array list, all bits are shifted in memory because of the creation of the new array. Then the array list acts like a list. Simply basically acts like a list. Okay, so Linked list also is the same. It acts like a list. Okay, it also implements list, array list and linked list. Array list is better for storing and accessing data. Okay, mas mabilis siya. And then while linked list is better for manipulating data because of no bit shifting. So drawbacks of linked list, one serious drawback of linked list, basically, it requires sequential scanning. So when we say sequential scanning, you are the element that you want to search for, the searching algorithm will always start at the head until it will found the element, and then it will proceed to the tail node, and then return the element that is found, whatever index ba, address, or whatsoever. Okay, so the search starts from the beginning and stops when either a search for element is found or the end of the list is reached without finding this element. So that is one serious drawback. So that is why array list is better for accessing. However, linked list is better for manipulation. If you want to insert or delete new elements or nodes. So there are other types of list structures: skip lists, self-organizing lists, and sparse tables. So we'll be discussing this in a different video. So that ends our presentation of our linked list structure. So I hope you have learned something on this lecture. Thank you for listening and watching. Again, please do like and subscribe this channel. Thank you.